Hey guys, Space Marine 658 here. Today we are going to be covering how to actually manually collect PSOs and what those are, how they work. We're kind of covering a lot of stuff here. So this is probably going to be a bit of a longer video. You'll probably be able to see down below that I've broken it up by chapter. Initially here right now, we're going to be talking more about what PSOs are, why we want to collect them, and a bit of information about how they work in Unreal Engine. So we're going to start off with this graph. Unreal Engine, the Epic team actually did a really good breakdown of why these are so important and why moving forward these are going to be a thing. That these are not just only affecting Unreal Engine, that these are going to be affecting most engines, and a lot of different engines have different ways to handle it. Specifically, we're just going to be talking about how Unreal Engine themselves handle it. So you see here, there's a loop. Now this is known as the PSO loop for Unreal Engine. So the way it works is you very first thing you do is you're going to cook/recook a UE build, and this is going to create your packaged game. From here, during the cooking process, it creates SHA shaders. Basically, these are the shaders that are built into the engine when you're playing the game. Now, when you run that, what it's done is it's compiled a lot of the information done, but it doesn't pre-compile the actual shaders because some of that pre-compilation depends on the actual type of graphics card you're using. It depends on what settings you're running the game at. There's a lot of different things that affect it. The OS that you're running on, all these different things affect those shaders. So there's millions of different shaders they could create you at cook time. The problem comes in that if you create all of those, you're going to create a massive bloat in the size of the executable. You'll end up getting like millions and millions of these things built up. If you tried to create a permutation of every single possible PSO that could ever exist across all of the different levels of graphical fidelity. So what they do instead is they basically precompile them all so that they're ready to be compiled at runtime. And then when they actually go to get used, these shaders get used, it combines the pipeline cache and the SHK to create what's known as the SPC, basically the shader pipeline cache tools. And so the best way you can think about this is the shaders used at runtime. This is the actual part that causes the hitching. This is what actually causes shaders to freeze for a second, because what it's doing is it's creating these right here and combining them with these to actually create the fully functioning shader. Now the good news is that once it's done with that, that's put into a folder, and your graphics card will reuse those, so long as you don't turn certain settings off in Unreal Engine by default. And so with that, you're basically, that alone will allow you to go through the process and be ready to go once you start the game. Now, there's a couple ways to handle it. What we're going to be talking about here is a more manual way for developers to actually grab these and do something with them to make it easier for your players. But some games handle them a little differently. Some, if you ever loaded up a game, for example, the Elite Dangerous series, when you start the game, it has a compiling shaders at the beginning. What's actually happening there is not, usually at least, not any kind of like actual necessarily like code running in terms of compiling shaders. What's happening is usually you've got a black screen or some kind of screen with that bar running, and in the background what's happening is a camera is usually moving through some kind of test level they've built with all of the different shaders that they think that they'll need. They try to use most of them up front, and it basically will go through and it'll build those so that way when you're playing the game you don't get that stutter. Now with that is a valid way to do that, but it can take a lot of time. If you've ever played one of those games, you can sit there compiling shaders for a good 10-15 minutes the first time you load it up. Of course, later on when you do it, it'll usually check and see how many are built versus not built. That way it can try and reuse them if at all possible. But with this process, what we're going to be doing is you're going to be doing this sort of ahead of time for your players. That way they don't have to sit there and wait for them to compile. They don't have to do anything. Now it does require a little bit extra work up front, but the cool thing is the way it works, and I'm going to show you here in a minute. You can actually make this something that any member of your team can do, or any QA members or anyone who wants to test the game. You can make it so they themselves can actually compile the shaders for you and provide them. Now there's a few plugins out there that will allow you to grab those and wirelessly send them back, so that way you can set it up for your QA team, so they don't even have to send them to you. They can just literally run the game at multiple settings and have them automatically sent back to you. But we're going to assume that you're probably a solo dev, because I know a lot of people are, and I'm going to show you how to do this, if you're doing it by yourself. But yeah, so once you have these basically created, what we're going to do is we're going to log them, so that way we actually have direct access to them. And then we're going to actually use a cache tool commandlet that comes with Unreal Engine to allow us to actually apply these to further builds. So basically you'll be able to grab the PSOs, we'll be able to put them in a folder, and then the next time we go to package, what it'll do is it'll actually pick up those PSOs and include them in the package build. So that way when you run it, it'll have them ready to go. But yeah, and then basically you'll want to repeat this. So as we're finishing off the loop here, you can see repeat process for cumulative improvements. Essentially, there's not a hard written rule on how often you want to do a process like this. It is a somewhat intensive process. My opinion is, as a developer, basically you want to do this. It depends on the length time of your game, of course. If you're making a game in like a week, you probably could just get away with doing it once right before release. If you're making a game over, 2 years, maybe you want to do it every 3 to 4 months, just because you're going to be adding new levels, you're going to be adding new items. You want to do it frequently enough that when you're doing it, you're not restarting from scratch every single time and having to play through every single level of every single game at every single graphical fidelity level. That can be quite intense. But instead you want to do it, often enough that you've got relatively fresh versions of these, without having to redo literally everything. So yeah, let's go ahead and jump into a little bit further here. So actually setting up your engine so that you can get ready to do this. Now, the good thing is a lot of these options are now on by default. As of, I believe, 5.3 and 5.4, they added a lot of these on by default. But just in case you want to go and check, you want to come into your actual project folder. As you can see here, I'm in my actual Starlight Brigade project folder. Go to your config, and in here you've got your engine INI, so your default engine INI. Now, there is a lot of different, let me make sure I'm telling you correctly. So there's a lot of different options in terms of where your actual project INI lives. Because if you're running on a Mac, I believe it's slightly differently. If you're running on Windows, it's slightly differently. So for example, I have a Linux version. Now the good thing is these are just the game INIs. In terms of the actual engine INI, depending on if you're on Mac or Windows, it should be in roughly a similar location. Now what you're going to want to do is there's going to be something called let's go find it, need shader stable key. Now, as you can see, I don't actually have that in here. So what you want to do is you want to grab this bit of text I'm going to grab here. And of course, the actual documentation is going to be linked down below, so you can follow along if you want to copy and paste. So what we'll do is we'll add a new section here, and this is going to be dev options.shaders and need stable keys equals true. And then what you want to do is go to your default game.ini. Inside here, you're going to also create another section as well. Let me just make sure I don't have it in here. It's called share material. Material shader code equals true. Yep. And you see, can't find it in here, which makes sense because I removed a lot of the stuff so I could show you all how this works. So you're going to add that. So it's this little bit of code here. script / Unreal Ed project packaging settings, and then share material shader code equals true, shared material native libraries equals true. Basically what this is going to allow us to do is actually allow us to create our PSOs. So to actually do that, these need to be set to true. Now these specifically are options you're probably going to need to add, because a lot of the other options that were added in CVARs are already set to true. It's just these couple of options here. So now what you want to do is you're going to want to go into your project and then go into your build. And then I'm making sure I'm telling you correctly, but looking to the right. Now you're going to have, depending on what build you're building to, for example, I've got both Windows and Linux. You're going to want to go in and go to your pipeline cache folder. Now that's assuming that you already have done this before. Now, if you haven't, this folder will not exist if you've not yet collected any. So what you want to do is go ahead and create this folder. So this is just called pipeline caches. Make sure I spelled that correctly. Yeah. And you want to make sure you spell it exactly like this, because what's going to happen is the cooker is going to actually find the recorded cache files in here and pick those up, so that when you cook the project, they'll be included in your packaged build. And then we're going to want to go ahead and go make sure our CVAR, let me actually double check. Okay, so our Linux doesn't have it either. So we'll grab this, go back to Linux, 12v. All right, and then if we go back to our config and our default engine INI, we're going to want to also look for r.shader. Actually, it's got a capital S. Sure. All right. So yeah, so we don't have it in here. So there's a r.shader pipeline cache.enabled. Now if we go, just type in shader pipeline. Yeah, so we don't have it in here as well. So what we can do is just under, I believe I've got everything set up correctly here. Let me just double check. Yeah, so let's go under here, under tick allow batching. We're going to also add this and set it to 1. There we go. Now, assuming we've got everything set up, we should be almost ready to go. What we're going to first want to do is actually boot up our project. And so I will be right back. All right. Now what you want to go ahead and do is actually go ahead and package your project. Now there's the project launcher where you can do this, or however you normally package your project. I actually have a script that I run that packages the project for me. I've gone ahead and done that, but you'll want to go ahead and pause this video and package your project. And once you're done packaging it, come back here. All right. Once you've got that done and you've got your project packaged, what we're going to do is we're actually going to go into that project. So for example, here I've got my Windows project. What we're going to want to do is actually run this, but we want to run this by logging the PSOs. So before we do that, let's actually go ahead and just start this up. And I want to show you what it looks like if we've actually cleared out those PSOs and the actual lag that you see in terms of visually as it tries to render out those shaders. So actually I'm going to run this here. This has logging, but it's also going to clear out the current PSOs. So we can kind of compare before and after. So you can see here, music's a little loud, but the engine there is supposed to have a flame coming out of it, but right now it's currently computing that shader in the background. And it actually takes quite a while because it's a Niagara shader, so it is quite a slow thing when it comes to computing. We'll give it a minute here. There we go. And you see, once it finished computing, now it's actually showing it. So let's go ahead and close this here. Now, of course, if we want to go ahead and log those, it's really important that we capture those. But first, to actually log them, you need to be able to run that exe with a couple of commands. So what I've gone ahead and done here is create a batch file. So let me show you how that actually gets created. So what you'll do is you want to create a text document. If you've never created a batch file before, you want to create a text document, name it whatever you want, and then you want to have the file be named .bat. That is a batch file. And what I've got here is I've just got echo off, title packaging game, because I just copy pasted this over from my packaging game up here, so you can ignore that part. And then we run cd. Now what this needs to be in these quotations, this needs to actually be a direction to your actual build. So as an example, I have my Windows build here, right? I'm trying to run this one. So all you need to do is go to your actual where your exe is and copy this up here, and then you'll paste it into here. Then you want to type in your exe name, which usually is going to be your game name.exe. And you're going to want to have a /clear PSO driver cache if you want to test and see what actual PSOs have not yet been built, and then log PSO. So once we actually include our PSOs inside of our project, what this will do is this will allow you to see which ones you've forgotten or not yet included, because they'll hitch. They'll take that second to load in and actually get generated. So it's a great way to force yourself to see which ones are not yet in the actual project. But yeah, so we did run this though. As you saw, we have that PSO. So let's go ahead and actually take a look at what that PSO looks like. So to find your logged PSOs, you're going to want to go to the save file. Now your saved file is going to actually be, because it's on your project, your local, you're going to want to actually go to your local disk, then your user, then your name, and then app data, which is going to be one of those folders that's sort of like grayed out. If you don't have hidden folders shown, you need to make sure to turn on hidden folders. But it's usually, most people have it on nowadays. Go into app data, then you want to go to local, then you want to go find the name of your game, because it actually creates a folder under the name of your game. So example, Starlight Brigade. And then under here, you're going to have your actual saved files. Inside of your saved files, you're going to have your collected PSOs. And as you can see right here, we collected a PSO. Now, to actually use these, we're going to have to do something to actually take this and turn it into something. So how do we convert these? So what we're going to need to do is do something called expansion. Basically, we got to take this and we got to convert it into a format that is actually useful for the cooker. So basically, we want to grab this, and then we're going to want to actually go to our project folder. It is this one. So go to your project folder, and then you want to go to your saved. In here, you're going to go to your cooked, and then go to the project, of course, and the platform name, and then the project name, and then metadata. And then there's going to be, you need to have a pipeline caches folder in here as well. So go ahead and create a new folder. Line, make sure I'm spelling this correctly, pipeline caches. All right, now that we have captured those PSOs, and what I've gone ahead and done is I've gone ahead and just saved them to a folder here. I've copied it over from my save there, and I copied it into a folder here, just so that way I have it in one place. I can keep up with it a little bit easier. Next, what you're going to want to do is actually go into your project folder after, because once you've compiled your project, it basically creates these keys that we're going to want to get a hold of. So we're going to go into our saved, and then in here, it should be under our, let me double check, under our cooked cooked. Yeah, there we go. Cooked. And then the platform that you're currently working with, you'll probably want to go into both when you're doing this. But for now, we'll just go into Windows. And then you want to go into Starlight Brigade metadata. And then there's going to be our pipeline caches. Now, remember how we created this folder in here? Now we have all these shader stable info. Now, what we want to do is we want to go ahead and copy the SHK files from this directory into the pipeline caches. All right. So now that we have our shader keys and our pipeline cache here all in one folder, what we're going to go ahead and do is we need to actually do the conversion step. So to actually do the conversion, you're going to need a couple of things. So first, we're going to go ahead and I've gone ahead and created a little file here. Let me go ahead and open it up. This is an example of what mine looks like. Essentially, you're going to want to run basically the same thing. So to do this, what you're going to want to do is go find your engine installation and then copy. Basically, you want to copy this. The only part that should change for you is going to be basically where your engine actually is. So for example, I have mine on my D drive. If you have it on your C drive or E drive or wherever else it is, you're going to want to make sure you include the correct drive letter here. And then the name and number of the engine, because it'll be iterated in that folder based on, what the actual number of the engine is. And then the binaries, Win64, if you're doing Linux or anything else, you want to do those as well. And then Unreal Editor /command.exe. From there, we're going to /run equals shader pipeline cache tools. This is basically a tool within that command. And then we're going to call the command expand. Now, the next parts need to be in quotations. That is just in case there's any spacing in any of the words. It won't throw an error if you have them surrounded by quotations. So this first quotation is just a relative path to those pipeline caches. Now I saved mine on my desktop in that folder PSO cache. So I basically just made a relative path to that PSO cache folder. And then I did what this is basically says all of the pipeline caches in this folder, go ahead and use those. And then I did the exact same thing, but for the shader keys there, the SHKs. And then for this last one, this is actually going to be what determines the which one you're doing. So for example, you can have SM5, SM6, Vulkan, whichever version you are converting, or if you're doing multiple, if you're setting up a batch file to do multiple of these, you want to have one for each one of those. Now for now, there's a whole lot of options, so I'm not setting up a batch file. But if you ever decided to do so, that's how you do it. You'd have one for the different versions. So for now, we're going to copy this command now that we have it. So for mine, I have gone in. So I've got the direction the path to the PSO cache folder. And then within here, what you're going to want to do is you're going to want to give it first a prefix. This is whatever you want. This is what you as a dev want to put the prefix as. It can be literally anything as far as I'm aware. Then you're going to want to have underscore the name of your project. This needs to be the actual name there. And then followed by this PCD 3D SM6. Now, of course, what you want to do is you want to look at, what are you using? So for now, because I'm going in the SK and I just have my SM6 in here, I'm just using those. If you want to, you could also do SM5. Android has their own version. I believe Linux, that basically for every version that you're releasing, you want to do PSOs based off of that. So once you have your command built, what you're going to do is go ahead and search for your command prompt, right click, click run as administrator. I don't think technically you have to run it as administrator, but I find that you run into less problems if you're running it as an administrator. And then what we go ahead and do is Control V and hit enter. And it'll take a couple seconds. What it's going to essentially do is go in there, grab the necessary items from those two. And it basically does what it says on the tin. It expands them, does what it needs to combine them, and you're going to be left over with this particular item. So this right here, this is the basically final product. So the cool thing is now we need to actually take this and include it in our folder. So let me go ahead and Control C. So now that we have our final version, what we're going to want to head and go and do is go back to our project file. So let me reopen mine here. And then within here, you're going to want to go to your build and then go to specifically the build for this PSO is for. And you want to go to the platform name and then the pipeline caches, which is the one we created. Go ahead and paste that in there. Now, you're going to want to go ahead and cook your project again. Now, I'm not going to be covering it in this video just because it is not necessarily directly related, but I have a batch file I use to actually build mine. So if you're curious about how to do that, I can always create a video on that. But for now, you can always open up the engine and package it there as well. I'll go ahead and let mine run and we'll come back when it's done. All right, that finished packaging. Now, normally what you can do is kind of look at the end to see, what got built into it. If you're doing it through the editor, you can actually go and it'll be on that document from Epic. Essentially, you can look and see what was actually included in there, how many stable PSOs. And you should be able to look and see, the binary PSOs down at the bottom, or pretty close to the end. But for now, that should be fine. So let's go ahead and we're going to actually go ahead and let me grab this. Make sure we have that log PSOs. All right, so now that we've got that added, what we're going to want to do is go in here and just make sure, yep, as you can see here, we don't have any saved PSOs inside of here. So what we're going to want to do is actually just open up that test build directly. So now what this should do is, if we've incorrectly added it, you'll notice that when it first starts up, that it'll actually take a second to show that flame. But if I've done everything correctly, we should see that start up almost immediately. It might take like just a millimeter of a millisecond to actually load the PSO, but as long as the cache has been correctly added, it should load up pretty much immediately once the menu loads up. And boom, there you go. As you can see, it loads up just fine. All right, so that pretty much covers the entirety of dealing with PSOs. Now there is a bit more of advanced topics here I'm going to cover very briefly. The documentation that I'm including in the description is pretty great on covering most of that, but we're just going to talk about it quickly. That way, if you want to follow along or at least understand better some of the other options and things that are going on with these, you can see that here. So next we're going to move on to actually talking about partitioning cache. So basically, one of the things that they recommend are creating basically bit masks. Also, PSOs already come with a bit mask called the game usage mask, but sort of they break down how to actually use that when you're talking about getting access to those PSOs, because when they currently are created, they're sort of a monolith. And that's sort of the default behavior, but you can actually break it down into smaller bite-sized chunks. The benefit of doing that is that you only load the ones you need. So they tend to take up a little bit less memory because you're less loading everything all at once into, active usage. And so with that, they've got a few different things here you can use. They got some example functions. First, if you're just breaking it down into maybe, a couple of PSOs, for example, here they have it actually using a function to avoid compiling them on different levels or different graphics quality settings. So basically, instead of, it's basically you set the game usage mask with comparison function rather than recording them on different levels. So basically you kind of do it all at once. As you can see here, and it kind of basically goes into that PSO and makes it a little bit easier to break down it into little pieces. But of course, if you've got a lot of things going on, or you want to encode more granular quality settings like they're mentioning. So if you don't want to have just like sort of like a default quality setting, you can break it down even further. The example they use here is a way to have a struct made of several bit fields and a custom comparison function to actually compare them. They do mention that this needs to be done early on during setup when saving or loading the user settings. And it's used basically during the recording process, but then also during compilation so that only the correct usage mask is actually compiled from the cache. Now let's move on to talk about limitations and future work. So basically they go on to talk a bit about how actually the cache's masks work. Right now they're all ones. Basically the idea is right now PSOs are not easy to split into independent bundles of content. For example, if you have a DLC that is using, certain objects, that PSO may be included in with ones that are more for like default content. And so that's some things that they want to add are some additional ways to break these down. Now with that, they do have some tools on actually compiling PSOs. So example here, they've got a way to actually start up it in different ways. When you start it up, you can set it in one of 4 modes, and this is also one of the 4 modes you can set it to when you're actually batching it. Paused, fast, background, precompile. So what do these actually mean? Pause is basically, like it says on the name, you suspend the actual compilation of them. Fast is basically for anything that you want to use as much possible bandwidth as you can, where your player is not really interacting with anything. That's a loading screen, that is non-interactive UI elements, that is, maybe like a elevator, level where you want to hide the compilation in the background. Anything where the player's really not going to be doing a whole lot. And it's called fast because you're compiling it fast. Now, then you have background. Background is better for when players are actually doing things, for navigating the UI. And they give a specific example of the UI in terms of where you still want the player to be able to interact with things and do stuff, but they're not necessarily moving about the world, because when you're compiling these, you probably don't want players moving around the world. It can cause some very weird things to happen. For example, in mine, when I first load up, sometimes when they're compiling, because they eat so much of your frame rate for that momentary second, it can cause physics to wonk out and things like that. And then you have precompile, which is basically using both of them with a usage mask, basically to compile them in fast mode for any that match that mask. So for basically, if you're going to start up the main menu, right, you can choose to use fast for the things that you need for that main menu, but then everything else you can do background. So it means really quickly it's going to grab those items that are needed now, compile them, and then move on. And then you can load. And then now that you've loaded in the background, it's going to finish compiling the rest of the items for things that you're going to need soon, but not yet. Now, the cool thing is with this, you can actually build this into your UI. So when you're starting up the game, you have that precompile. You pick those objects that you want to have precompile. And then you can actually get the number remaining and actually make a progress bar. You can actually, or if you don't want a progress bar because you don't know how long it's going to take, because you could, very first time you call it, you can kind of guesstimate, there's 3,000, you want to go to 0, so you have a loading bar go from 3,000 to 0, but you invert it to 0 to 100. But let's say instead, you just want a plain loading screen. This can tell you, how long to leave that loading screen running. The loading screen, instead of, waiting for it to finish and then going, you might be able to just set it up so that way they can just know, hey, when this hits 0, I can go. So it just goes, all right, I'm going to check this function, on a timer, maybe every second. That way it's a little bit more smooth when it finishes, instead of being a jarring cutoff of the loading screen and then jumping to the next thing. You can have it so that it checks every second, and then once it checks that it's successful, then maybe run like an animation or something to finish the loading screen, right? A lot of AAA games do that, where the loading screen will finish and then it'll go dark, and then boom, the title screen pops up or something like that. You know what I mean? But yeah, so we'll go ahead and move on. They talk about more about the actual user cache file. What a user cache file is basically is like the local pre-compiled. So you're not going to cover everything in the PSOs. If you did, it could be very large, and some of it maybe content players never run into. The goal with the PSOs is just to cover most of the content, right? To cover the general gist of the content. So that way, when things do need to get compiled in, they're very small, they're very quick, less hitching. And so the idea with this is that by default, they basically look at your game engine version. So in your project settings, you can have a engine version that you iterate, and they'll both compare to that. But then I think they also compare, I believe it says on here, like a number of days. They like to keep track of time. Yeah. So the default value is 30 days. So if it's been longer than 30 days or the engine version has changed, it tries to refresh them just in case anything has changed or anything's different. Because what will happen is when those are generated, if they're invalid, it can cause an extra slight amount of delay. But it's usually not too big of an issue because they're already themselves causing hitching. So they're not, making the hitching really any that much worse. The benefit of the local ones, though, the user cache files, is that when they're done for those little items, the things that aren't covered, you get a benefit of that's then stored. So the next time the player runs into that shader or comes, leaves and comes back, it's still there. It's kept around. That way you don't have to worry about them having that hitch every single time they go in there. It's just the very first time that they interact with that shader. All right. And then they talk a little bit about interactions. We're not going to worry about that too much because, yeah. So basically they're just saying, with the pre-caching system built in, the manually collected cache is not necessary. Technically that is true. The benefit of the manual cache system is that you're a little bit more fine-tuned. It's a little bit easier in terms of like really truly tracking where things are going. Now, of course, you can go in and set it to only use the user cache or exclude the pre-cache PSOs. But I find by having them, everything just seems a little bit smoother, a little bit ready to go. And then I've got an FAQ if you have any questions or anything, that you'd like to know more about. They talk a little bit more about there. But yeah, so that's pretty much it for me. If you have any questions, definitely leave them down below. But otherwise, good luck and good hunting.